So in a velocity time graph, you get the same shape. Again, the analysis or the interpretation, the approach should be the same. You take the quantity on the y-axis upon the x-axis, check which physical quantity represents that, and then relate it with the variation of gradient. Now here, the gradient actually keeps decreasing as in the previous case, but the gradient will be equal to v over t, and we know that that's equal to acceleration. Hence, the acceleration keeps decreasing in this process. Correct? Acceleration is decreasing. Now, if you are asked to find the acceleration at any particular point in this, you will follow the same method as before. Say at 5 seconds, if they want to know the acceleration, please don't substitute this value over this, because that doesn't give you the actual value. It only gives you an approximation there. So you have to draw the tangent, take the gradient of the tangent, and then give the value. I hope that's clear. Now, for velocity time graph, we also have one more calculation. They may ask you to find the distance or displacement covered in that for a particular section of a journey. So what do we usually do? What is the format? It is area under the graph, right? Now here, since it's a curve, so how do you calculate? Say for 5 seconds, you want to find out what is the displacement or distance. So my aim is to find the area of the section under the graph, correct? So does this represent, again here I've noticed a few of the students try to assume this to be a sector. It cannot be a sector, because this distance and this distance may not be equal all the time. If it is equal, yes, you can use that formula. If it is not, so how do we approach? It's not a geometrical figure where you can directly substitute a formula and find. Instead, you have to find an alternate method. There are two methods which are accepted. One is counting square method. Since all these graphs will be plotted on grids, you can find the area of one grid, right? I'll just show you a sample here. So you have grids. You find one area of one grid by multiplying the quantity on the y and x axis. So if this 1 unit represents 2 meters per second and this is 1, the area will be 2 multiplied by 1, 2. So every square represents 2 meters. So you count the number of squares below the graph, multiply it with 2. But what's a disadvantage here is your answer will be further away from the accurate answer. The reason being, when it is a curve, if you're counting the squares, the actual method teaches you if the square is more than half. It's like approximation, like 0. When you're rounding off numbers, very similar to that. If the square, the curve passes through more than half of a square, then you count that as 1. If it is less than half, you ignore, right? So equal to or more than half of a square, you count that as 1. Less than half of a square, you ignore it. So both will compensate for each other. So you will get a rough estimation of the distance that is covered. As I said, this is not accurate. It is only very closer to accurate value. So you count the number of squares. So this I will omit. This I will omit. This also I will omit. But all this I will count as full squares, and then you multiply it with 2. So 1, 2, 3, 4, 5, 9, 13, 16, 17 multiplied by 2. So 34 meters will be the displacement or the distance covered in that particular section. Getting it? That is counting square method. There is another one which is much more accurate than this one, but it's a little bit time consuming. So if you do not have time to complete the paper, if you're in a hurry to finish and you have left it for the last minute, you can go ahead with the counting square method and quickly finish it off. If not, if you have time, then what you do, you split this into sections. Actually, the smaller the sections, more accurate the value would be. Okay, here I've divided into 3 sections. Now, if I just draw the border, you will notice I'll get a geometrical figure. Right? Now this is one figure. This is second one. Now this one is third. Now if you notice, the curve, the entire section is almost covered. Only this area is left. A smaller portion of this area will be omitted in my calculation. So that may not affect much. It could be neglected because you all are aware there will be a range of answers given to you in such calculation. So you would be on a safer side. Now, how do I calculate the area? This is the area 1, 2, 3. Look at the figures. This is a trapezium, correct? With parallel sides, these two. Similarly, this is also parallel side. So 1 and 2 are trapeziums with these two as parallel side for area 1. So you take A, B. What would be the height? This would be the height. Actually, if you turn the paper, it will be easy for you to identify the trapezium, right? So trapezium formula is what? We have trapezium like these two are parallel sides, A and B, and this vertical distance would be the height, correct? So if you relate that with this, these two are the parallel sides. So that's A, this is B, and the distance, this is anyway perpendicular to this line. So that would be your H. What's the formula? Half into A plus B into H. You substitute in that, you will get area of 1. Then find very similar formula, area of 2, area of 3. You add them all up, you will get a more accurate answer. Alright. So non-uniform graph analysis, you have got to remember 3 points. Please, if the gradient quantity is to be determined, you must construct a tangent to the curve and then proceed. Alright. Now, if the area is asked, there are 2 ways that you could solve it, as I said, based on the time, counting square method, or by actually calculating, split it into smaller sections. See, if you split it into this area, if you split into 2, you will just notice that more area will be omitted in my calculation. Say if I choose to divide it into 1 trapezium and 1 triangle. In this, when I drop a line here, straight line, you can see this area and here. So more area will be left out in my calculation. Right? That's omitted. So your answer will not be very close to the accurate answer. But the method is correct. But if you're very particular, minimum 3. Don't go to smaller than that. You're only going to waste your time. Alright, 2 to 3 sections you can divide. As I said, keep it to 3 sections and quickly, before going for examinations, just practice a few questions, because see, the distance that you are measuring, you have to take it from the y-axis so that you don't make mistakes in calculations. Alright, now in the next video I'll be talking about scale diagram, and probably in the third video I'll talk about ray diagrams, how to construct it easily. See you, bye.